Dear students, we are on the CEC Gurukul lecture, and today we are discussing the energy storage system, energy storage devices which are used to store the various type of energy. In the previous lecture, we discussed the various type of the energy storage systems to store the electrical energy, mechanical energy, and so on. Now the question is how we choose the best energy storage option. So choosing the best energy storage option is very much important. So what is the best energy storage option? Each of the different energy storage technology has an application for which it is the best suited, which need to the considered in the implementation. Like key issues that must be assessed are the charge discharge profile, the storage capacity, capability, and potential scalability. These are the main points when we choose the storage option. That assessed are the charge discharge profile, storage capacity and capability, and the potential scalability. In addition to the cost of the storage, the expected lifetime in terms of the cyclic frequency before degradation sets is also need to be factored in the cost benefit analysis. So the rapid cost declines that the lithium ion has been and are expected to continue in the future and make battery energy storage the main option currently for the requirement up to a few hours and for the small scale residential and the electric vehicles applications. But as the storage duration required increases, the option shifts to the either the thermal, mechanical, or the pumped hydro, or in the future hydrogen. So batteries are not the only way, and if we make such a fast and more energy storage and longer lifetime energy storage devices, rechargeable devices, so we have to shift it. So there are the various electrical, electromagnetic and the electrochemical form of energy storage system, like the capacitor, supercapacitor, and superconducting magnetic energy storage, that is SMES, and also the superconducting storage coil. And in the electrochemical, where we use the battery energy storage system, BESS, where we use the flow battery, rechargeable battery, and ultra battery. We discuss one by one, and this is a chart where we are discussing about the various type of the energy storage devices, electrical, electrochemical, and the mechanical, and they are also having the subparts. So next, that is a very important for the storage devices, is the supercapacitor. We will discuss one by one the various electronic storage devices. First we take what are the supercapacitor. Supercapacitor are used to hold the incredible enormous amount of energy, electrical charges. So electronic devices called supercapacitors are used to hold incredibly enormous amount of electrical charges, and they are also refers to as the ultra capacitors or the double layered capacitor. Supercapacitors are the ultra capacitor, or can call it as a double layer capacitor. Supercapacitor stores the electrical energy utilizing two methods: double layered capacitance and pseudo capacitance, as opposed to the traditional dielectric. So in the supercapacitor, energy utilizing by the two methods, double layered capacitance and the pseudo capacitance. Double layer capacitance is the electrostatic, is the original, whereas pseudo capacitor is the electrochemical. Hence supercapacitors function as a hybrid of the conventional capacitor and the batteries. You see on the screen here we define the double layered capacitor. So the utilizing this method, capacitors as high as 12,000 to the that can be produced. The capacitance, double layered capacitance, is the electrostatic in the origin. So the capacitance of the supercapacitor is more than the 15 millions times more than that of the self capacitance of the entire planet Earth, which is only approximately 710 F. The maximum charge voltage of the supercapacitor is typically between the 2.5 to 2.7 volts. In contrast of the high maximum working voltage, that is conventional electrostatic capacitor we may have. There are the various type of the, what is the difference between the various type of the supercapacitor, and what are the difference between the supercapacitor and the capacitor. Generally we use the capacitor, and how we can differentiate the capacitor with the supercapacitor. A capacitor is a passive electrical devices with two terminals that retains charge as an electric field between its metal plates, and it consists of the two metal plates that serve as the anode and the cathode of the electrodes that are separated by a material that is known as the dielectric. That is a capacitor, as we all know. In the supercapacitor is the another name of the doubled layered capacitor, and that is a ultra capacitor or is a supercap. And active carbon is used as the electrode material for the supercapacitor's electrode. Now it is a we define the in the later lecture, next lecture, that what are the active carbon. So active carbon is used as the electrode material for the supercapacitor's electrode. In contrast, the normal capacitors which use the dielectric material as a separator between the anode and the cathode, supercapacitor use as a separator. So next difference is the current seeks to travel through the insulating material when the source voltage is supplied between the two terminals of the capacitor, but the material resists the flow of electrons. Either electrostatic double layered capacitance or the electrochemical pseudocapacitance, or the combination of the two, which is known as the hybrid capacitance, is used by the supercapacitor to store the charges. In the third difference, the insulation material continues to obstruct the flow of electrons even though the voltage across the capacitor terminals is equal to the applied voltage. So this resistance phenomena causes a shift that has effect of storing the energy as a electrostatically charged field. Now in the supercapacitor metal foil electrodes, the layers of the activated carbon makes up the supercapacitors. The separator is sandwiched between these foils, and iron permeable membranes such as graphene used in the contemporary supercapacitors, which serves as the separator and allows for the exchange of the electrolyte ions between the electrodes. What is the basic design of the supercapacitor? Now we see on the screen that there is a typical construction of a supercapacitor which use the power source, collector, polarized electrode, Hamilton's double layered, and electrolyte which is having the positive and negative ions, and the separator. So electrochemical capacitor, that is the supercapacitor, consists of two electrodes which are separated by an iron permeable membrane that is known as the separator, and electrolyte ionically connected both the electrodes. We connect the electrolyte on both the electrodes. When the electrodes are polarized by the applied voltage, ions in the electrolyte form the electric double layers of opposite polarity of the electrodes polarity. So for example, we can take positively polarized electrode, and we'll have a layer of the negative ion at the electrode. Electrolyte interface along with the charge balancing layer of the positive ion and absorbing onto the negative layer. The opposite is the true for the negative polarized electrode. What are the type of the supercapacitor? Supercapacitor are classified into the three types. Number first type is the electrostatic double layer capacitor. As the name suggests, double layer capacitor, two electrodes, a separator and electrolyte are components of this kind of the capacitor. The mixture of the positive and the negative ions dissolve in the water is known as the electrolyte. A separator separates the two electrodes. So, the supercapacitor, in which the one form is the electrostatic double layered capacitor having the two electrodes, one separator and an electrolyte. And the electrostatic double layer capacitor of the carbon electrode or their derivatives used in this supercapacitor is significantly high. So, the capacitance, the double layer capacitance of the carbon electrodes or their derivatives used in these capacitors is significantly high. The electrostatic double layer capacitors have a smaller charge separation than the normal capacitors, and it is in between the 0.3 to 0.8 nanometer. Pseudocapacitor, electrochemical pseudocapacitors are another name of the pseudocapacitor. That is another type of the supercapacitor, and these capacitors are conducting polymers electrodes or the metal oxide electrodes with substantial electrochemical pseudocapacitance. So, by transferring electron charges between an electrode and an electrolyte, these components store the electrical energy. A reduction oxidation reaction or the redox reaction can accomplish this. So, redox reaction we have in this type of supercapacitor, pseudo supercapacitor. Third type of supercapacitor is the hybrid capacitor. As the name suggests that the two capacitors are used to create the hybrid capacitors. So, the double layered capacitor and the pseudo capacitor techniques are used to create the hybrid capacitors. Different electrodes with the various properties are utilized in these components. The ability of the one electrode to display electrostatic capacitance and the ability of the other electrode to display the electrochemical capacitance. So, a few instances of the hybrid capacitors are the lithium ion battery capacitors. So, hybrid capacitor is the combination of the double layer capacitor and the pseudo capacitor. What are the characteristics of the supercapacitor? As we are using nowadays, and the supercapacitor are used in many electronic components, then what are the characteristics to choose the supercapacitor? Charge time. Number one is the charge time. The charge and discharge time for the supercapacitor are equivalent to those of the regular capacitor. Due to its low internal resistance, high charge and the discharge currents are achievable. So, a mobile phone battery is a good example of the battery that often takes several hours to fully charge, but supercapacitors can reach the same charge state in the less than 2 minutes. Next is the specific power. The maximum power output divided by the total mass of the device is used to compare the various technology using the specific power of the battery or the supercapacitor. The specific power, which is one of the characteristics of the supercapacitor, the specific power of the supercapacitor is 5 to 10 times greater than that of the batteries. For instance, a typical supercapacitor has a specific power of about 10 kilowatt per kg. So, whereas lithium ion batteries have the specific power of 1 to 3 kilowatt per kg. So, third characteristics is the cycle life of supercapacitor. Batteries only have a cycle life of 500 times or more. However, supercapacitors can be charged and discharged millions of times and have a virtually and virtually a limitless cycle life. And as a result, supercapacitors are highly beneficial in the application that frequently need to store and release energy. Safety of the supercapacitor. So supercapacitor batteries are safer than the conventional batteries when mishandled. So supercapacitors do not heat up as much as batteries do because of its low thermal resistance. But batteries have been known to explode owing to excessive heating when short circuited. So now the next we discuss the working of the supercapacitor. These were the characteristics of the supercapacitor. Now the working of the supercapacitor. The supercapacitors use electrostatic or static electricity to store the energy. Between the two plates of the supercapacitors, electrolyte solutions are ions that are both positive and negatively charged. One of the supercapacitor's plate typically develop a positive charge while the other plate acquires the negative charge when the voltage is placed across the plates. So as a result, the positively charged plate attracts the positively charged ion in the electrolyte solution, while the negatively charged metal plates attracts the negatively charged ions. On the inner surface of both the plate, a thin coating of the ion is deposited. Now, as a result, an electrostatic double layer forms, which is like connecting two capacitors in series. So, each of the two resulting capacitors has a high capacitance value because the space between their charge layers is relatively small. So calculating the super capacitors by total capacitance by dividing the C1 into C2 by the C1 plus C1. So what are the application of the supercapacitor? We are having various applications of the supercapacitor. Electric vehicle, if we use the supercapacitor in the electric vehicles, we use in the windmills, we use this supercapacitor in the flywheel machines, in MP3 players, camera flash, automotive industry also uses supercapacitor for regenerating the braking. Industrial electrical motors and static memories, we use the various supercapacitor. What are the disadvantages of the supercapacitor? As these supercapacitor discharge themselves more frequently, and this is significantly higher than a battery. They discharge themselves very frequently. And the next disadvantage is low voltage exists within the individual cell. Because of this, series connections are necessary to attain the greater voltage. If we compare the electrochemical battery with the supercapacitor, which is there is a significantly lesser amount of energy stored per unit weight for an ultra capacitor. This is equivalent to 3 to 5 watt per kilogram as opposed to 30 to 40 kilogram for the battery. In the comparison of the batteries, it delivers a poor energy density, and this is equivalent to between 1/5 and 10th of the battery's energy. So that it cannot be utilized in the circuit with the AC or higher frequency. There are some interesting facts about the supercapacitor. Electrochemical double layer capacitors, supercapacitor and the ultra capacitors are distinct type of the electronics, and it can function as an energy storage system, that is a plug and play. Energy density and power density are calculated using the electrode area and the weight. Voltage balancing is not necessary unlike the other battery sticks. Supercapacitors are electronic devices that are used to store the extremely large amount of the electric charge, and they are known also the double layered capacitor or the ultra capacitor. Thank you very much.